Okay, so the graph of f prime is shown in the figure. Sketch the graph of f if f is continuous, meaning no holes or gaps, and f of 0 is -1. So we do know our original function goes through the point 0, -1, and it has these slopes, basically. And it looks like constant slopes as we go through the x axis and look at the curve or whatever the shape is. So let's try to see what the original function looks like, provided we're looking at its slopes up here. So I have a positive slope, and then another positive slope, and then to the right of 2 I have a negative slope, it looks like. And the fact that the derivative is not curvy and it's linear means that if I have a constant derivative of 2 between 0 and 1, my function must just be a line between 0 and 1, right? So let me put underneath it what my original function must look like. Let's do 2 and 3. So again, if I'm looking at f prime, signs, I've got positive slopes, and then I've got positive slopes here too, and then I've got negative slopes. Now, it's a constant slope of 2. It's not increasing or decreasing in any way. So it looks like it has no concavity. It's a constant slope of 2. And then between 1 and 2, it's a constant slope of 1, right? Because the y value is 1, and here the y value is 2. And I also have to keep in mind that it's not differentiable, because there's undefinedness going on at 1 and 2 and 0. But we'll see what happens when we try to get the graph. And then between 2 and 3, it's a constant slope of -1. So basically, I must be dealing with an original function that's linear, because the slopes of it is always constant. Different ones, but constant slopes. So between 0 and 1, the slope is 2. Let's take care of this first. And we know my graph goes through the point 0, -1, my original graph. So I'm going to start at 0, -1, and then I'm going to make a linear function with slope 2, because between 0 and 1, the slope is a constant 2. So up 2 over 1. That must be my function between 0 and 1. Again, the slope of this black graph is always 2, which is what that tells me up above. Then between 1 and 2, the slope is always +1. So between 1 and 2, I'm going to go from here up 1 over 1. I'm kind of not drawn to scale, but you get the idea. Up 1 over 1. So the slope between 1 and 2 is a constant 1. So all these slopes between 1 and 2 are represented by this 1 derivative function. And then between 2 and 3, I'm going to a -1 slope, because my derivative has a constant value of -1, meaning my slope is a -1 over the entire interval. So from this dot, I'm going to make a slope of -1, down 1, 1 to the right. So between 2 and 3, that slope is always -1, which means I have my continuous function that basically consists of 3 line segments. And the reason there's these holes in my derivative is because these are sharp corners. So that's a sharp corner. That's a sharp corner. Hence, it's not differentiable there. They left it open. And that, I guess, maybe if I continue, I will have a sharp corner after that, and over here too they left it open, not differentiable. So maybe to the left it would be a sharp corner or something. So my original function must have been consisting of a bunch of lines to give me this derivative above it that consists of slopes that are constants between certain intervals.